Okay, good morning, everybody. This is Abdul Sheikh from Sintra. I'm joined by Simon Rice, one of my senior systems architects today. Glad everybody could make it. This is a repeat of our webinar from last week's launch of the Oracle Database Appliance X3-2, also the version 2. We've got a nice, short, sharp, but very informative webinar this morning covering the details of the Oracle Database Appliance, but also covering off some of our specific implementation, track record, and our own feedback in terms of our experience with the appliance so far in its 18 months since it's been launched in Oracle Open World 2011. So very quickly, many of you know us already. In terms of Sintra, we've been around for some time, but effectively the agenda we're going to cover today will be a quick recap of engineered systems, a little Sintra background, the ODA version 2 or X3-2, it's known now, and what's new with that, and specifically a little bit about the Oracle Database Appliance Manager software, which is what makes unique. The appliance unique in terms of its value proposition, and then some of the new features around the Oracle Virtualization stack on the ODA, and then a little bit about private cloud strategies using the appliance. So very quickly, I think many of you know us already, but we do regard ourselves as a bit of an authority on the Oracle Database Appliance. We have been the leaders in the appliance deployments and implementations for Oracle globally, having deployed, I think we're in something coming up to about 30 units now, mostly in the US with some of the UK. Today, actually, a lot of our audience is spanning both our UK audience, our Irish organization in terms of our office and locations on our customers in Ireland, as well as our US base as well. So a wider audience today. We were awarded by Oracle in recognition of the focus and investment that we made in terms of time to this product, and as a result, 2012 we were proud to receive the award for Specialized Partner of the Year for the appliance itself. And when you're dealing with partners, it's good to know that you're dealing with a specialized and qualified partner. Oracle has a specialization program which recognizes our skills and specific references from customers and actual transactions that we drive when it comes to core technologies around Oracle's database. Specifically, as most of you would expect from a qualified partner, the Oracle Database core technology, the performance tuning aspects on top of that, Oracle Real Application Clusters, RAC clustering is, of course, a key technology under all of Oracle's engineered systems on the database stack. Golden Gate for real-time replication for both availability and reporting and warehouse strategies. And of course, Oracle BI and warehousing on top of that. And then lastly, the hot topic of the day is very much the engineered systems products around Oracle's Database Appliance and Oracle Exadata, which we'll touch on briefly now. So real quick, in terms of the services focus from Sintra, I think we can skip through this pretty quickly, but we are focused very much on driving business value through new technology upgrades and refreshes. When we talk about architecture evolution these days, we talk about more of a revolution rather than evolution. We're looking to drive very significant increases in performance to the application, changing the user experience significantly, improving operational efficiency, improving the application, batch processing, report activity, and very, very fundamentally and simply focused on driving real value back to the business when it comes to our investments in technology these days. And overall, delivering on the tagline which everybody's talking about these days, which is really doing more with less, and that's what a lot of the engineered system strategies is about in terms of delivering value. Optimization is a key word around our architecture services, coming in and really looking at existing infrastructure, see where there's opportunity for significant optimization in terms of storage utilization, removing a lot of wastage at the storage architecture level, improving efficiencies and utilization of CPU cycles, and overall ensuring our utilization levels on our technology infrastructure is much higher than it typically is, which we typically do find with siloed environments where you have dedicated servers to dedicated purposes, and those do often result in a lot of wastage, both in terms of hardware resources, but also software licenses, which can also become, of course, a very significant cost when it comes to Oracle. So we're certainly focused on managing that cost and being compliant at all times. Risk management is at the core of Sintra in terms of our blueprints and mitigating risk of deploying any new technology. So everything that we provide in terms of our client deployments is driven off proven blueprints. And then that's rounded off by our proactive managed services around the database and the BI warehouse stack around providing proactive Oracle support to ensure systems stay healthy and don't degrade and are compliant in terms of their security and availability needs. So very quickly, engineered systems, it's been probably a 3 or 4 year roadmap now. Oracle has had a big focus around Exadata. It's probably the primary product focus, very much focused in the top tier customers. But the Oracle Database Appliance is what we would regard as a channel-led or channel product from Oracle's perspective, firmly applied to the broad market where customers are looking for the same value and the same proposition in terms of increases in performance, but more of a rapid deployment model and a much lower risk in terms of removing complexity. We've seen a tremendous adoption of the appliance around those principles. In addition, the ZFS storage appliance is also gathering very significant momentum, and we're seeing a very significant uptake of the ZFS storage appliance in the NAS space, specifically addressing price point issues and performance issues with competitive platforms such as NetApp and other products such as HP Left-Hand Storage or Dell EchoLogix, typical Tier 2 storage platforms that may have challenging I/O performance profiles or may just be costly, where ZFS comes in at twice the performance and half the cost, which is the official tagline, which we are seeing to be delivered by Oracle. In addition, some of the other complementary products, EchoLogix for middle-tier WebLogic environments, also supporting the Oracle BI infrastructure, providing a high-speed middle-tier layer platform, and then some of the periphery items around big data and Spark Supercluster, which are probably now just getting some attention from the customer base. So as we know, when it comes to pure database, the Oracle Database Appliance we regard as the on-ramp to engineered system. It's very much the low-cost option when we talk about a low cost of entry, but still a significant value in terms of the cost savings around hardware in pre-integrated hardware stack with a 2-node rack cluster in a box, effectively in a 4U condensed format. So that gives us a tremendous amount of capability in terms of CPU, memory, and storage, but in a very condensed form, which if you were to engineer that form factor would typically with EMC storage or Dell servers, you'd be looking at occupying maybe closer to half a rack and at a greater cost. So from a hardware perspective, it's very attractive. And as we see, there is now Exadata comes in at a lower cost price point with the eighth of a rack, which is a new format with the X3 version of Exadata, which we own ourselves in our Dublin data center, which we use for benchmarks and POC testing. Very much a related product in terms of similar specs, but of course Exadata brings with it some additional secret sauce around optimizing the database with compression, infinite band storage, and intelligent storage as well. So that gives us some very significant uplift in performance, but of course at a higher cost. So just focusing on the Oracle Database Appliance very quickly about the specs themselves, it's still a 4U form factor. So when you talk about 2 servers and a disk shelf tray, effectively we're achieving a very condensed form factor. The version 1 ODA was in a single chassis, a single wrapper, if you like, which is now with ODA X3-2 has evolved to a multi-chassis, so the 2 servers and the disk tray are independent, but still pre-engineered, pre-configured, and pre-cabled when Oracle's delivering that, so there's no additional integration required. 2 database servers, and those database servers of themselves are actually identical specs to the Exadata when you talk about the compute nodes within Exadata, but now we have an upgraded and the latest family of Sandy Bridge Intel processors, providing us with 2 times 8 cores per node, so that's a total of 32 cores in the Oracle Database Appliance version 2, which is a significant capability from a CPU perspective, and of course that can be managed at the BIOS with the Oracle Subcapacity Core Management, which is a feature that allows you to only enable the CPU cores that are required, or in most cases, most systems are I/O bound, and therefore that's very attractive in the ability to manage that, and also therefore manage the subsequent and related Oracle software costs. Memory's increased quite significantly from 96 to 256. So just a few years ago, we were building databases of 2-3 gigs of SGA and PGA. Quickly, we saw that jump up to 30, 40 gig SGAs with 64 gig machines. HP DL380 is a very typical machine, a DL360. Now it's more typical that we're seeing, a minimum 64 gigs per server in terms of database footprint, but more typical 128. Oracle's really upped the game when it comes to memory now to 256 gigs per node. Memory is getting cheaper, so that capability now allows us to have much greater amounts of data in cache with the SGA and PGA, therefore minimizing our round trip back to disk and increasing our performance further. Storage has always been a hot topic with the appliance because it is a restricted form factor in terms of how much storage we have. So the initial version, the version 1, did have 20 times 600 gig drives, which gave us 6 terabytes usable in a double mirrored RAID 10 configuration. That's now evolved to 900 gig drives, giving us 9 terabytes usable, 18 terabytes of raw storage, which is more than enough for most, actually more than enough for most transactional systems and most warehouse systems, but allowing us now to be much more confident in following a consolidation strategy and not worrying so much in terms of some of the limited capacity. Oracle's also now, of course, addressed the ability to have a storage expansion capability with the addition of a second tray, taking us up to a total 18 terabytes usable, which is tremendous. And of course, built into the storage layer, we also have SSD drives, which gives us a boost in our redo log performance on databases. So combining all of our SSD optimization, the IOPS from the fast SAS drives, our extended memory pool, and the latest processors, we're seeing some very significant increases in performance. Some of our previous implementations, very typically we would see a minimum of 3 to 5x improvement in performance on legacy platforms. In some cases up to 20x, again, depending on the code themselves, but specifically purely from the hardware, it was very attractive from what we saw. Software versions in the stack are identical, so it's still Oracle Linux 5.8 with the Oracle Unbreakable kernel, which is an optimized version of the Linux kernel, providing some additional performance benefits, and the database version 11.203. And then, of course, the Okay, so let me hand off to Simon, who's going to help me with the rest of the presentation, and then I'll jump back in later. Thanks, Simon.
Thanks, Abdul. So we're just going to drill down now into the value propositions around the ODA and particularly look at the tagline that Oracle has for its simplicity, reliability, and affordability. And we're going to cover some of these sections now. So in terms of simplicity, I think this diagram pretty much speaks for itself. But the fact that with the Oracle Database Appliance, you don't need to worry about the integration of it, the administration of the storage, the network, and having specific skill sets around those parts. It's I'd hate to call it a self-managing system, but it's certainly lower in terms of maintenance and management than most custom-built environments. Deploying it is extremely simple. It's really a case of racking it, cabling it, and then running through a wizard-driven install that gets you to a point of having a kind of a dummy test database on there. In terms of a typical installation timeline, we'd normally see a week between getting the hardware delivered on site to having a pre-production environment ready to be populated by the end of the week. So it's, in comparing that to a normal rack environment where you may be looking at 4 to 6 weeks for that kind of timeline, you can see that there are some scenarios where really an appliance-based architecture is the only way to turn around a project in that space of time. In terms of reliability, there's a huge amount of redundancy built within the database appliance, and I think this kind of comes back to the point that this isn't anything new. This is commodity Sun hardware, which has been around for a while, and really the same database servers are used in Exadata. There's nothing new there. The storage tray is really a JBOD. So as you would expect from Sun hardware, you have redundant network cards, redundant power supplies, fans. All of that stuff is hot swappable. In terms of the redundancy on the database server layer, we obviously have 2 Linux servers which can be clustered in a number of ways, which we'll describe, and redundancy around the private interconnect for the cluster as well as the public network coming into the appliance. On the storage side, we have the ability to either simply mirror our storage in a RAID 10 configuration effectively, or triple mirror it for extra redundancy if we feel that we really need that level of redundancy. The software that runs on here, again, it's nothing terribly new apart from one thing that we would refer to as a secret sauce here. But we run Grid Infrastructure 11.203. We run Oracle Database 11.203. And as you can see at the top here, we have a number of deployment options. We can go for fully active load-balanced rack. We can go for an active-passive cluster using Rack 1 node, where the database is effectively up on the primary node and can fail over automatically to the second node. Or we can go for a single instance database, which is only available on one node, can be manually started on the second node, and will be automatically restarted if it fails by clusterware. So there are a few considerations, and obviously each one of those has its own license implications as well. In terms of the operating system we're running, it's currently Oracle Linux 5.8, which is a very stable, tried and tested release. We're running the unbreakable enterprise kernel on there, the UEK, rather than the Red Hat compatible kernel. That gives us some performance improvements, and it also allows Oracle to provide faster bug fixes and patches to their own kernel as opposed to the Red Hat kernel, as they have control over that. Now, the Oracle Appliance Manager provides a large number of benefits. We'll drill into each one of these in turn, particularly around how it monitors the actual physical hardware and has its own diagnosis capabilities. So in terms of performance, I think quite rightly the Oracle Database Appliance isn't, it's not Oracle's flagship performance product. That's clearly Exadata. Exadata has its own storage cells and hybrid columnar compression and InfiniBand, which can really give you an enormous performance boost. However, the Oracle Database Appliance, compared to commodity hardware, does have some really big benefits, particularly around the way the data is striped with ASM. So the drives are all split into an inner and outer split. So the faster portion of the drive is dedicated to data, whereas the slower portion of every drive is dedicated to the flash recovery area, to the RECO disk group. And that typically gives you around a 50% improvement in terms of the IOPS that you get from the drive. So it's a substantial improvement just from that split. Data is striped with ASM, which is a best practice and gives you optimal performance there. And the fact that the storage is direct attached means that we have optimal throughput through the internal expander cards and HBAs, so that we get the best path to the disk that we can. And I think the overall message here is that it is out-of-the-box tuned. Having redo on SSD is a best practice there, and the response times that we see are really comparable to enterprise-class SANs, so around 3 to 5 millisecond reads and faster than that on writes. I think the affordability of the appliance comes in two real portions. Certainly the ease of manageability and maintenance of the appliance is a huge feature, and these numbers speak for themselves. I'm sure we'd all be glad to have 2,000 extra hours of our years back. But really, the time we save on installing, deploying, maintaining, and supporting the appliance can be huge. And we're certainly seeing evidence of that from the appliances that we've deployed over the last 2 years and their reliability. The other aspect, of course, is the ability to disable cores from day one when we deploy the appliance and enable cores over time as we require them for capacity. And obviously, if we compare that to a traditional model of having to size our servers and have them fully enabled from day one for year 3's growth, as you can see, the license cost savings there in terms of Oracle software licenses are tremendous.
I'm just jumping in here. There's a couple of points to make as we get through these slides, but one of them is some of the trends we're seeing around the appliance where previously, for example, customers who were running standard edition who just could not afford the financial leap to get over to enterprise edition, now the appliance makes that completely viable. So if you compare it to, for example, a DL380 running 2x6 cores, 12 cores in the box. Then, so just talking about the appliance themselves, specifically on the capacity on demand, we're seeing a huge trend when it comes to the use of the appliance. Our customers are previously on standard edition, and they could not generally make the leap to enterprise edition. So the appliance with the ability to enable the cores as needed really makes an enterprise edition viable as a lower cost of entry into enterprise edition.
Thanks. So yeah, that's a very good point. We see the appliance very popular as a way for getting from standard edition onto enterprise edition, and also as an on-ramp onto engineered systems in general, and particularly for people who are looking to try out and really prove the value of engineered systems before they get into major investments around things like Exadata. So we've already talked about some of the hardware specs. I think, high points here, as we've already mentioned, are we've moved from Westmere to Sandy Bridge processors, which we're seeing around a 40% improvement purely from the technology change there, as well as a move from 6 to 8 cores. As Abdul's mentioned, we now have stacks of RAM, 256 gigs, so half a terabyte across the cluster, which really gives us a huge scope for consolidation. And the obvious increase in storage, which removes, some of the limitations we had on the ODA version 1 around the storage limits there. The external disk tray is obviously another huge benefit. We can only add one disk tray, and again, that's for the reason behind only allowing one additional disk tray is to optimize performance to the disks from the internal HBAs. However, the move to 18 terabytes of usable is a huge deal in terms of the ODA's development. On the software side, as I mentioned, pretty much everything here is what we already know and use across the board, and is very tried and tested. The only, I say, new thing, the only additional component is the Appliance Manager, which has really been around since for the last 18 months, 2 years, and has grown in terms of features and usability. So we're going to drill into the Appliance Manager here, particularly around the speed of provisioning and ease of provisioning, the management of the storage and patching of the appliance, and then looking at some of the lesser known features around the hardware validation and diagnostics. So in terms of provisioning, whenever you set up an ODA, and this is nothing new, you have an option of confirming your database class, and this really determines your CPU cores and memory, the number of databases that you can theoretically put onto the ODA if you're using internal storage. And on the next slide here, we have some other metrics that are determined by your choice of database class. So these are all chosen during the initial deployment of the ODA. However, there's also a DBCA set of templates where you can use these sizing classes as templates and build on top of them, build in your own custom parameters and so on. So, as much as it's a rapid, easy, templated installation, you still have the option to customize these yourself and, do things like changing block size and character set and whatever else you would want to. So in terms of provisioning, the operating system is already installed. You already have Oracle Linux when the ODA arrives. There may be a degree of patching required, but typically that's a pretty rapid process. Really, there's no expert knowledge. You don't need to be a rack DBA or an ASM DBA in order to install clusterware and get your database up and running. It's all a very much a wizard-driven, templated process. And as well, there's no need to worry about, hey, is this patch certified for this? If I install this patch on grid infrastructure, is it going to break my database binaries? All of the patches are bundled into what they call bundle patches, which are just a single zip file that you download, uncompress, and install. So the whole package really is validated by Oracle. In terms of the storage configuration, it really automates all of the things that were painful of building commodity hardware rack clusters in the past. So actually discovering your disk, how the LUNs are presented, how the multipathing is configured, partitioning those disks for optimal configuration as well. All of this is handled by the Appliance Manager during the initial configuration. So the way that the disk groups are configured, we obviously have our data disk group for our actual Oracle data itself. We have our Recode disk group, which is used for archive logs and general flash recovery area usage. And we have the option of saying we either want to take our backups internally to within the flash recovery area, in which case we get about a 60% ratio of our flash recovery area to our data area, or we can say actually we want to take our backups externally, perhaps to something like a ZFS storage appliance over NFS. And that changes the ratio to 80% of data, 20% of archive. The redo disk group is the one that's created on solid-state disks. So you tend to see, if you were to look at an AWR report after deploying an appliance, you tend to see 0 millisecond wait times on your redo logs because the SSDs simply fly. So the appliance manager also, after the deployment, monitors and tracks the configuration of the storage. So if we were to add the second disk tray, the appliance manager would automatically pick that up, rebalance our data across the new set of disks. However, more importantly, I think in terms of resiliency, it monitors the disks for any issues. So it looks at things like, is a drive dead? Has it got some kind of predictive failure issue, or is it performing badly? And there are actual thresholds here where we can actually say to Oak, if a disk is showing a particular issue, then we want you to take X action against it. The benefit this gives us is that generally within ASM, if we have a disk that dies, we have a disk timeout threshold where the disk will stay within the ASM disk group and not be dropped typically for 3.6 hours. The Oak daemon will actually proactively offline the disk and remove it from ASM before that, depending on the type of issue that it's seeing there. So really that sort of de-risks any disk failures. So yeah, I think the underlying message here is that the storage really is zero admin, and in almost all of our ODA deployments, we really just leave ASM alone to do its own thing. It's configured optimally out of the box. The multipathing is great, the performance is great, and we very rarely even look at it. So in terms of patching, as I mentioned, there's a bundle patch which you download a single zip file and unpack it, and it then covers all of the firmware on the hardware. It covers the operating system, the Oracle Linux upgrades themselves. It covers things like your management software, your automatic service request, your your Sun hardware patching interface. It then covers the appliance manager, grid infrastructure, and your Oracle databases. And you can typically do these in multiple windows. You can typically say, I want to upgrade the shared infrastructure, which would be our firmware and our shared disk storage. After you've done that, you then have a choice, well, do I want to upgrade grid infrastructure? And after you've upgraded grid infrastructure, you have a choice about whether you want to upgrade your database software. And if you do, which databases you want to upgrade to the latest patch set. So for example, if you're running 11.202, you could leave a couple of databases on 11.202 whilst upgrading one to 11.203, and it will automatically maintain all of the Oracle homes for you until they're no longer required. So the patching process is really this simple. You download the patch bundle, the zip file, you unzip it to the correct location, you update the shared infrastructure, which is point 3 here, so things like the ILOM and the BIOS. You then upgrade grid infrastructure, and then you update your databases as required. And each of steps 3, 4, and 5 could be completed in separate service windows to minimize downtime. In terms of diagnostics, the big feature here is automatic service request, and this has been enhanced as the ODA's lifespan has gone on. It's a lot more comprehensive now in terms of what it covers, but a typical scenario is you have a drive fail in an ODA. You may not even know about it. It's in the data center. It's not causing any issues because your data's mirrored. You'll have an orange maintenance light on it in the data center. In terms of ASR, the ASR daemon would actually recognize that. The appliance manager software would say to ASR, I want you to raise a service request for it. And while the appliance manager is actually removing that dead drive from ASM and managing the availability of the storage, the automatic service request is raising a service request with Oracle, having a new drive sent to you in the post, or having an engineer arranged to come on site. And typically the first thing you'll know is when you get a call from a guy saying, I'm here to replace your drive. So it's a very, very slick automated process. The next point here around the Oak CLI Validate is that there are ways that you can, through the Appliance Manager command line, validate your hardware components. And that's been hugely useful for us, for example, during Hurricane Sandy, to be able to just run a single command that validates everything from power supplies to fans to disks across the board, really. In terms of diagnostics collection, this is a really useful feature. If you choose to raise a manual SR instead of an automatic SR with Oracle, there's this diag collect feature, which will allow you to gather all of your cluster logs, your operating system logs, your appliance manager logs, and your database logs into a single zip file, which you simply upload to Oracle support. So it saves some time in the management there. So moving on into the virtualization platform, and I think this really comes back to the use of the ODA for consolidation, whether it's consolidation of multiple databases onto a single platform or even applications in this state. So really, OVM has been around for a while. It's now becoming a proven and stable technology. The way this works is you now have the option with the ODA. Do I want to install a bare metal installation of ODA software, which gives me my database environment, or do I want to install an OVM environment, of which my database component is just one part of that? So really, it gives us a lot more granularity on how we configure our ODA now. This slide, I think, sums things up nicely. But effectively, we have a DOM0 environment, which is our OVM repository. This has our OVM software itself, our hypervisor. It also has the templates of the virtual machines that we want to install on there. We then have ODA base, which is our standard ODA environment. That's our Oracle Linux, it's our appliance manager, grid infrastructure, and database. So ODA base is really what you would have on any quote-unquote normal ODA that's not running virtualization. And then on top of that, you have a number of domain views, which are our virtual machine guests. And they can really be anything from, Intel Solaris, they can be Windows, they can be Linux, whatever you choose really there. Cool, so really the ease of doing this is huge. You can actually just install a domain 0, which will kick off a largely automated installation of your ODA base and unzip it in there. And ODA base, and I guess this is an important point to outline, it behaves exactly the same as any other ODA. So you get your same amount of usable storage, your same amount of memory, aside from a small portion which is allocated to DOM0. You then have a choice of how many cores you want to allocate to ODA base compared to how many cores you want to allocate to your other virtual machines, and the same with memory. So you can effectively slice up the ODA's resources between your ODA base and your virtual machine guests. You have the same deployment options around single instance, rack 1 node, or fully active rack. And, as you would expect, deploying virtual machines is very easy. So I think the bottom line here, and I'm going to drill into one aspect of this in more detail, is that OVM is as with everything with the database appliance, it's a very automated, wizard-driven process, which is easy to implement and easy to scale up. WebLogic, we're going to just cover a couple of slides here very quickly, but WebLogic can be installed in the same way, and it's really the same process that we've had for the ODA for most of it. So we actually install the ODA in our normal way. Instead of downloading just our Appliance Manager bundle, we download WebLogic Server as well for the ODA from the Oracle eDelivery site. We run our Appliance Manager as we normally would to create our ODA base, and then we run a WebLogic Server configuration, and that will look very familiar to anyone who's set up WebLogic in the past. Now what's important here is that it gives you an extremely optimized version of WebLogic. So here, as you can see, you have your WebLogic VMs, you have your application domains, and you have your software load balancer. But the important thing to note is you have a choice of whether you want to go for what they call good availability, which is an active-passive WebLogic cluster, or high availability, which is an active-active WebLogic cluster. A huge point here is that WebLogic comes optimized for rack out of the box. So through a templated wizard-driven install of WebLogic, you end up with active grid link configured for your rack environment. So it will do all the good things around transparent failover of WebLogic connections, depending on the load on the rack nodes and so on. So really, I think the message there is it's not just a rapid installation, it's a highly optimized installation as well that can give you great performance improvements and stability. So I think, I think the key message is that virtualization is here to stay on the ODA. It's got a number of important use cases. and particularly some things that we're seeing are people just saying, hey, I want to do more with this hardware than just run a single database on it. Or, for example, I'm stuck on Oracle 10G. You know, I can't move because my application has a dependency. Is it possible for me to run 10G on an ODA? And virtualization gives us some options there, you know, that we can leverage for that. So I'm now going to hand back to Abdul to wrap up. Thank you.
Thanks, Simon. Great job. So I think that really emphasizes the value that ODA brings in terms of simplicity, highly available environment, rapidly deployed. Performance is a significant advantage, and also the built-in scalability around the ability to vertically scale our processors and also add storage. But I think the biggest point that's attracted a lot of customers previously in the last 18 months to this platform is the on-demand licensing and really making Enterprise Edition viable, where previously maybe they haven't had that option. And of course, you know, a single solution in the box. So that really leads on to this very busy but interesting slide. It's our view of what we think is the appropriate strategy for a organic private cloud. Now, often, sometimes, you know, when you think about cloud and Oracle's perspective on that, it's, you know, Exadata certainly is a tier 1 extreme performance platform, and we agree with that in terms of its positioning in that level. But when you think about how cloud typically is funded, how that strategy evolves, you need an organic building block approach. So you need the ability to build as the business demand increases, and really the ODA is the key to that, and the ability to provision and deploy ODAs, and therefore get into more of a organic growth in terms of our expenditure in how we grow and fund a private cloud strategy. And as that evolves and our footprint increases, then our ROI on the platform then justifies the expense up to moving up to a tier 1 on the Exadata side as well. I think a key technology as an enabler across this particular picture is ZFS. So if I'll quickly go from top down, we see on tier 1, we're showing our top tier extreme performance databases in red, showing us that the highest level of availability, the highest level of performance, highest level of customer experience that we want to demonstrate there. Our customer-facing apps would probably be in the tier 1 category. Tier 2, where we still need good performance, we still need high availability, but we don't need the extreme performance. So some of the internal HR apps, PeopleSoft, SAP, JD Edwards, EBS, those are ideal to be deployed there, where we have more of an internal audience around our employees and our internal HR and finance departments, where performance adequate, you know, still very good performance, but not blinding performance is required. And then tier 3, where we have some of our lesser tier applications, maybe reference type architectures, you know, master data management type architectures, where it's not necessarily a high throughput transactional system, it's more of a reference architecture. Then tier 3 is ideal for that. And what's interesting about tier 3 and tier 2 really is using the internal storage within the ODA, which gives us a good amount of performance there. Tier 3 moves into using the appliance as the head, or the provisioning, where the databases are actually presented, but you'll see that the storage for tier 3 comes from our ZFS pool, which is beneath that. And ZFS is really, we think, a key enabler as part of the private cloud strategy, because it not only satisfies the most obvious use cases around fast backups, cloning for dev test and so on, but really it facilitates the ability to have, for the first time, a reliable NFS-based infrastructure where we're using an extended tier 2 storage pool for our database needs, where previously maybe NFS was a bit of a concern. But certainly with the DNFS client now with Oracle, with the optimization and the power of ZFS, I think that's a tremendous combination of ODA plus ZFS. And at the bottom there, you'll see our non-production uses around our QA and pre-production environments, which still require a performance profile, so they're reflecting some of the production performance that we get from ODA. Our test and UAT environments, which are now utilizing, again, ZFS for more of a high-capacity storage pool. And then development in green on the bottom right, this is where a lot of the savings on storage are being seen with ZFS, with the ability to create virtual clones of our databases. In one case, we have a community of 50 developers where we are provisioning a single terabyte database every morning out to those developers in a virtual sense, so actually not using any storage, and they get a full production copy of their production database. So, and again, these are features that are commonly found on platforms such as NetApp, but NetApp certainly does have its limits in terms of how many clones you have, and some of the performance that you might see from a clone. So the ZFS certainly takes that to a next level in terms of the price point and the performance of that. So I think that pretty much wraps it up. I think the key message we'd like to leave you with from our perspective, we are database architects, experts around the database infrastructure, whether it's a legacy platform, whether it's a roadmap you need to take your existing environment to a new strategy around engineered systems, coming in, helping you build a business case to be presented to management, building an ROI model, and really showing where some of the value can be had in terms of your applications and what it means to user experience and actual throughput on your applications and processing, and ultimately what it means to additional opportunity, business opportunity to your organization. That's our job, and that's typically how we start engagement in helping build that business case and then provide the more blueprinted deployment and then the ongoing managed services around engineered systems as well as traditional architecture. So we'll welcome you to reach out to us. Here's our contact information, and you can also follow up your local account manager within Sintra as well. So I think we've overrun just slightly, but thank you everybody for your time. We'll be putting this recording of this webinar up on our website early next week, so you'll get that under the webinars page on our website. But in the meantime, if you need a copy of the slides, certainly reach out to us, and we will look forward to some follow-up conversations. Thank you. Have a great day.